Which of the following bonds is the least polar? And then we have a choice of basically A through D. Is an HSE bond, a HF bond, an HS, or an HO bond the least polar out of these four? Well, let's get into it. Now, when we're talking about being polar, or the opposite, nonpolar, this comes from polarity. And anytime that you see these P words, right, the nonpolar, the polar, the polarity, these always stem from the chemical property electronegativity. Now, electronegativity, by definition, is the attractiveness of one atom to pull electrons from a chemical bond to itself. So basically, if, I'm just taking the HSE, for example, right? I see a single line there. That means that it's a single bond. And anytime that you see a single line, that represents a covalent bond, right? And a single line represents two electrons. Electronegativity discusses the attraction of these electrons in the bond. And a polar bond would mean that there would be an unequal attractiveness, that one atom would pull the electrons more closer to it. And always the atom that is the more electronegative is going to pull those electrons to it. So that's all that electronegativity is. Now, maybe we'll say attractiveness of electrons in a chemical bond. So if you don't have a bond, right, and you're just talking about a single atom, you can't talk about electronegativity because electronegativity comes with a bond. So it's the atom's attractiveness towards the electrons in a bond. If we want something to be the least polar, that means that we don't want any polarity, right? We don't want to be polar. Least polar would be basically most nonpolar. So you're either polar or you're nonpolar, basically. And if you're nonpolar, that means that the bond, or the electrons in the bond, have no pull. Which means that the electrons in that bond are not going to be attracted to one atom or the other. They're basically just going to be sitting pretty down, right down the middle as much as possible. So we need to find out which one is going to give us the most nonpolar bond. Well, this comes from the electronegativity trend. So if we don't know the trend, I highly recommend memorizing the trend on the periodic table. And we could, simplify the periodic table by just drawing a box. That's all you basically need, right? We don't really need to know the numbers, but we just need to know the general trend. But it's easy to remember because electronegativity goes from F to F, right? Corner to corner, basically, of the periodic table. The lowest electronegativity is all the way down on the bottom left. Big bad boy francium. And as we go to the other corner, up and up and up and up and up, we hit fluorine, which is the other F, right? So we got FR to F. This is where the highest electronegative elements are. And it turns out that fluorine is the highest electronegative element, which means that fluorine is going to be having the highest pull. And on the flip side, francium is like, whatever, I'm not going to pull those electrons. I'm not attracted to it. So basically like no pull, or the lowest pull, quote unquote. So, if we wanted to know the increasing or decreasing across periods and groups, just know that as you go across, you will increase, and as you go up, you will also increase in your electronegativity. So now we just got to find out where these electrons are. Or not electrons, but where these atoms are located on the periodic table. Little tip and trick, right? for these types of questions, don't even worry about the atom that is identical for these, right? These all have hydrogen. So if they all have hydrogen, that's not going to play a part into determining which bond is going to be least polar. We got to look at the ones that are different. And we just got to see where there are. Now, we already mentioned big bad boy fluorine. Fluorine is the highest electronegative element. It's going to have the highest pull. That means, basically most polarity if, we're keeping the other element itself. So this one would be the most polar because you have the most electronegative element here. We are looking for basically the least electronegative element. That would be negative. The least electronegative element out of now these three. Well, we just got to find out where selenium, sulfur, and oxygen are on the periodic table. And if I do a little, thing over here, maybe we'll. I guess I could just draw that again. I just kind of want to make it as close to the periodic table as possible. But just know that right next to fluorine comes big bad boy oxygen. Right below is sulfur, and then right below that is selenium. And maybe I'll take this out here. We'll go like that. We'll go outside the periodic table. And then we'll just draw that line again. Okay. So, as we go up on the periodic table, we are getting more and more and more and more electronegative. So the more closer you are to fluorine, the more electronegative the element. The farther away you are, the less electronegative the element. So can you tell me which one would be least polar? Would it be the one that is with oxygen, sulfur, or selenium? Yeah, you got it. It's the one that's right next to selenium. Selenium, for this, is the least electronegative element. And we have come to the answer, negative. And just to reiterate that means that the electrons in this bond are not going to be pulled, basically, to one atom or the other. It's going to be pretty much like an even split. Fluorine, on the other hand, the electrons in that bond are totally going to get pulled towards the fluorine. So let's box off HSE, and we are good for this video. Okay, what'd you think? I hope this helped. Nope, this doesn't have an exclamation point, so let's put it there. Okay, beautiful. Yeah, thanks for coming out. Coming to the computer or the iPhone or a phone, Android. No discrimination here. Yeah, but thank you for coming to the video. I hope this helped you. Let me know in the comments. Love to talk to you guys when I get a chance. And I hope you're doing well out there. If you want more practice problems, head on over to our website, glazersguide.com. The link is in the description and at the end of the video. If you haven't been on the website, there's tons more problems like this one with all video solutions to them with me and my brother Andrew. We do deep dive videos as well for topics. So come check it out. All right? Fun place to be at. All right. I'll see you next time. Bye-bye.
For more practice and for more fun, go to glazersguide.com.
And for more practice and for more fun, come on, go to glazersguide.com.